All right, if you are watching this video, then you are interested in learning about the crash data analysis tool. And in this video, we are going to take a deeper dive into the query tool. So Eric, if you want to maybe go ahead and drive here, we'll take a look at some of the options, as well as some of the limitations of the crash data analysis tool.
Okay, yeah. So as we showed in the intro tutorial here, you can click on the big button once logged in and once verified that you have the correct access, either basic or advanced. You can then click on the query tool button here from the CDAT main page. And it will pull up a screen that's similar to the import tool, but it'll follow through a series of steps that will ultimately get us to a safety score for a selected county, route, and then a mile point range.
Can we put something maybe here in Fayette County just to kind of go through an example of the tool?
Certainly, certainly. That's a great place to start. And as we go through, I may point out some things that are up and coming for the tool. We do have a large release planned for the next fiscal year. And one of the things we plan to do with that update is to create another module for intersections. So if you're looking for specific intersection analysis, this tool really isn't optimized for that yet. But we're getting there. That's our next one of our next moves. In addition to having a map interface to better help select your county route mile point, and that'll be pretty clear based on what Paul just suggested. Because if we want to do something in Fayette County, we got to know our routes. We have to know our mile points in order to do anything meaningful without a map. So you click on the county tool here. You can hit letters on the keyboard if you want to jump to a specific county. And here I'm going to jump to Fayette. You'll see a please wait pop up occasionally. It's going back to the server. It's hitting the database, and it's updating the form. So in this case, in Fayette County, all of the prefixes that are available on the routes are shown here in a radio buttons. And this drop-down box here lists all of the routes. And as you can see, there's so many routes in Fayette County. It's usually pretty helpful to go ahead and click on one of the filters to filter for a specific route. So maybe we'll look at New Circle, which is Kentucky 4. So I'll click the Kentucky prefix option. Now our routes are all filtered to anything in Fayette County and anything with a Kentucky prefix. Kentucky 4 is numerically the first one, so it makes it pretty easy. It's already selected. As we scroll down, we're faced with more options. We have the ability to show all of the mainline routes, the ramps, or both. And what those mean are the section IDs past the route number. And if you want to get a little more advanced with what these features actually mean, you can click on this link here. It'll take you to a page on the Transportation Cabinet's website that explains what that section ID is. But basically, most of the time, you're going to be just looking at the main line of the road. And that means it's the cardinal direction. It's where most of the data is tied to. So for traffic volumes, roadway geometrics, and things like that, generally speaking, we'll look at the mainline route. But if you want to get into ramp analysis, you can show ramps. Ramps is another specific feature that we want to add to the next fiscal year update as well. You can query it by ramps. We can't do a whole lot of safety analysis with ramps right now. The last thing you can choose is a mile point range. By default, it shows you the start and the ending mile point for the route that you've picked. In fact, this is really good trivia for any folks that live in Lexington. How many miles long is New Circle Road? And there you have it, as 19.2. And that's consistent with the exit numbers you'll see along New Circle as well. Paul, does that make sense?
The whole road length, or do you want to kind of narrow it down at this step?
That is a very important consideration, and one of the things I want to demonstrate as we go through the tool. So let's go through and select just a small segment from 0 to 1. But then I'm going to come back once we've learned the tool a little bit more and show you the real impact of segmentation because it can make a big impact on your safety analysis.
Okay.
So right here, I'm looking at from mile marker 0 to mile marker 1 on New Circle Road. So we'll move on down to step 2. Here you have the option to choose various severity levels. Now, generally speaking, we use the CABCO scale, and CABCO is a scale that's used by most states that are MUC compliant in the United States and many agencies around the world. And the definitions are listed next to the codes. So it is worth pointing out that in 2017, there were slight changes to the categories. This was another effort to be more MUC compliant. But generally speaking, these are the scores that you can use for the crash type. Now we've added 2 other unique and maybe kind of unique to Kentucky severity scales. One is U, where the injury severity is just unknown. And this happens in some cases, maybe in parking lot crashes and others, where there's just not a whole lot of data, or the police officer didn't put an injury severity for any of the people that were involved in the crash. And that just means the database, everything's null. So we generally assume these are O crashes, so property damage only, but it's just not certain. So when you're doing analysis, if you want to optionally turn those on or off, you can. Generally speaking, I think it's fine just to leave them on. But since the way they're coded in the database does show up as a null, we can't for sure categorize it as an O.
I've seen those pop up before for like hit and run, where somebody's hit a parked car and then left the scene. And I can see how that would be something somebody may want to omit for certain types of analysis.
Yeah, and that's a very specific example of a null injury type. There are many of our unknown injuries that are actually a result of a hit and run, where there was only the car that was hit was the car that instigated the crash report, and yet no one was in the car because it was parked, but the person that hit the car, the driver and all the passengers in the car that did the hitting and running, it's unknown. They could just have had no injuries. They could have left the scene, with a towel on a bleeding head. We just don't know, because they weren't there. They didn't get reported. So again, as you point out, that's something you may or may not want to include in your analysis. If you include any of these, we're just going to treat them as O crashes. And again, if you optionally want to remove them, you certainly can. So that's a little getting into the weeds on it, but it's something that when you really get on a deep level of looking at the analysis, you may or may not want those. So otherwise, we use the CABCO scale, and you can choose them there. Here you have the option to filter based on specific flags, as we discussed in the intro. Now, these are generally pretty complicated filters that are based on multiple fields in the database. So it's not something you want to do manually, but we've kind of worked with the Transportation Cabinet to develop kind of a consistency on how to look at these different types of crashes or different emphasis areas if they're part of the Strategic Highway Safety Plan. And you can see all of the details of these flags by clicking the link here, and it'll take you to a page that'll describe what codes we use to define these. Now, the one catch to this, go ahead, Paul.
Say, and maybe this is the catch you were leading into, but these are checkboxes, not radio buttons. Are these an and, or are these an or when it comes to filtering the data?
These are an and just because of the way the web page is designed and the way the query flow works, we need to make these to where if you check this box, it's going to apply to all of the crashes in the query. So checking more than one box is not recommended unless you really want to look at only commercial vehicle crashes that involved a motorcycle, and that would be a pretty small sample size, I would think. So you really just want to pick one of these. We do have the option where you can pick more than one. Based on the users, we may eventually change that to radio buttons, so you can only pick one if no one ever has a need. So the second to last section here is a road type. This is generally to stay consistent with a lot of our published reports, such as the crash rates and the crash facts reports that we do every year. As I said, this tool really isn't designed for intersections yet, so we recommend doing a non-intersection analysis here.
And
You can
by default.
That's on by default, yeah. You can optionally include intersections or limit only to intersections. If you do that, you definitely want to have a very narrow segment size, because if you get too wide, you're going to end up having a lot of roadway mileage in between intersections that's not going to be included in the safety analysis. Again, this tool is not built for intersections yet, so I would stick with non-intersections at this point. The other two are kind of optional. We look at crashes that occur on public roads, and we can optionally omit crashes that occurred on parking lots. Being that we're using Count-Around Milepoint to do the query, most likely you're not going to have to worry about private property or parking lots, but every once in a while you'll get some crashes that are coded on the mainline road, which actually occurred in a parking lot or on a private drive. So if by default, these are going to be excluded. You can optionally turn those back on or off. Does that make sense, Paul?
It does, yeah. So once you've made your initial selections here, I guess the only other thing to do is to go ahead and run the tool and view the data. Is there anything else somebody who's doing analysis should consider at this point? Is there any limitations we haven't discussed?
Generally speaking, this is pretty straightforward. We'll get into the detail of the importance of segmentation in a moment. I would generally suggest against trying to run this tool on the entirety of a route in a given county, and we'll point out why that is in a moment. But yeah, otherwise, going through here, you can check all the boxes as necessary. I think it is important to consider severity when you're talking about what SPF you're going to use. So we'll talk about that in a moment too, but you probably want the severity filters to match the SPF that you're going to use. And I'll point out how that can be checked too.
So generally, the default options are the best options until you know otherwise.
Correct. Yeah, and again, we recommend all 5 years for this analysis. Again, that's pretty fitting with the SPF tool or the SPF analysis as well. So
one question about the 5 years there. You said that the CABCO definitions had changed in 2017. Does that affect the 5-year averages at all, or are they pretty consistent just with new definitions attached to them?
No, this is something that we're probably going to see an impact of over the next couple, 2 or 3 years even. Because they changed in 2017, we do have 3 years of data where we use the older definitions and 2 years where we use the new definitions. The real difference here it's going to come down to the police officers' perception of injury type. Now A is suspected serious injury and suspected minor injury. Well, what we've done with the changing of the codes was to try to take some of the guesswork out of the police officer's determination of injury. They're not medical doctors. They don't see the same things that we'll see in a hospital when we start coding data in the hospital level. So by making it say suspected, I think it gives a better impression of what the police officer thinks, because before it was incapacitating and non-incapacitating. And those really are terms that the police officer really isn't really going to have a good judgment call for those levels of injury types. So you're going to see a little bit of kind of shifting in the numbers in A and B crashes over the next few years. But obviously in 3 years that should all kind of wash out, and we should be dealing with all apples.
Part of the value of the 5-year stretch, then it averages out.
Yeah, and again, if you think that's a problem for the analysis that you're doing, you can uncheck some of those years and look at it, in 2 different bins. But I suspect overall it's probably not a big issue.
Great.
Yeah. So clicking the View Data button pops up that pesky please wait window. It can take a little bit of time to run the query based on the road type you're choosing and the the segment length. And again, if you're going too long, you know, you're going to run into other areas as well. So when you hit the view data button, the roadway data panel is now visible. The first panel we see talks about the roadway data. So as we mentioned before, we're integrating crash and roadway data, and we're doing that using counter route MilePoint. And moreover, we're doing that using the Kentucky Transportation Center's KTC route and KTC MilePoint. These are our post-processed route and MilePoint definitions, and we've gone through a series of algorithms to help improve the location data. And we've seen how this can really help in some cases. So now that we've got a post-processed county and route, we are going to match to the Transportation Cabinet's Highway Information System, their HIS system, and we're going to try to get the linkage to the roadway information. So for this stretch of road, this is what we would call a good segment, because we're looking at 4 lanes, 12-foot lane widths, 10-foot shoulders, a depressed median. We're looking in a large urbanized area. So we're on New Circle Road here. We do see, and I do show intersections here just so you're aware that there's an intersection within the segment. Now, when we say intersection in this case, we're really talking about as a ramp.
Okay.
I mean, that's meaningful because you're going to have your more conflict points where people are joining and leaving a limited access facility. So using this information, you can actually shift your MilePoint ranges to optionally include that ramp or not to include it. The last thing shown here is the curvature class. So for this whole segment, this 1 mile of roadway, they're all Class A curves, which is pretty straight. Well, it's a straight.
Pretty desirable looking output if somebody's wanting to develop an SPF for this segment, then, right?
Yeah. So this is what we would call a very homogeneous segment. It's very similar from start to end. There aren't any major changes in geometry. So yeah, this is a good quality segment.
Now,
And we'll,
there's a couple of things I think that are maybe worth pointing out. One would be that show table button, and the other would be the fact that the titles are clickable. Do you want to maybe go into some of those functions now?
Absolutely. So the show table is helpful if you want to kind of dive into some of the variations that's happening along the segments. So if you hit the show table, you can see all of the variations in geometry and where they occur on the MilePoint. So since this is just a 1 mile segment, we can see them all in one screen. And what this shows us is that, again, the geometry is very consistent throughout. Now, the one thing that I may point out is that you can sort these by clicking on the titles. So if you're looking for something specific, but the other thing is that the segment start and end points that you choose up top are based on the crash query. And we're going to match it as best we can to the HIS segments. There may be some over or underlap occurring. And as you can see here, we have about 600 of extra length here because this segment went past the 1 mile mark. That's okay. We're, again, just using this as a screening tool. But again, you can just pop this open and look at variation. And I'll show this again when we get something that's a little more, varies a fair bit. So the other thing that you mentioned is the titles are clickable. And down below, you have the option to choose what happens when you click on the title. By default, if you click on the title, and let me find the only one that actually has some variation in it. Clicking on the title here, pops up a table below that shows the amount of mileage that's non-intersection versus the mileage that's in an intersection. This will be more meaningful when we click on a title down below when we look at the crash data. But it does allow you to take the data in chart form and look at it tabularly. The other option is you can have it switch between a bar graph to a pie chart. And then optionally, you can even have this do both of those. So just clicking on the whatever option you want to use throughout this session. But now if I click on the same intersection type, it will change that to a pie chart. Just might be easier to view, give you a better idea of percentages, that kind of a thing.
It'd be
Now,
good for a quick visual if you need it for a PowerPoint presentation or a report. Just grab a screenshot right off.
certainly. And this setting here applies to every chart below for this analysis. So you only have to set this once per session, and you'll have the same functionality throughout. The other thing that you can optionally take a peek at is we have information on the different curve classes, as well as the different intersection categories and so on in our About page here that you can click on. So this same functionality is going to occur in the panels below. So the very next table, since again, we're looking at a pretty homogeneous segment of road, that's a good sign. We can move on then to our crash data. So the next panel is about crash data, and it shows you up top how many crashes were found in this 1 mile segment. Again, you've got the ability to show a table. If you click on this here, you can see information about the each crash record, all 67. And now you'll see we're using pagination. So you'll have to click through these to look at various crashes. You can sort by any of the fields by clicking on the title. And then one other nice option is you can actually pull up optionally the PDF of the crash or just read the narrative for a given crash. Now, since we're probably going to send this video to multiple users that may not have advanced access, I won't click on them in the video. That way we're not actually showing a PDF. But those are available to you at the crash level.
Access at that level.
Yeah, so that'll be for
not available to you.
Yeah. If you're a basic user, you just wouldn't see those, and there would be other redactions as well. Now, if you are an advanced user here, again, you can click the download button, and it'll download this entire database, all 67 crashes, into a spreadsheet, and it'll also include a lot more fields. We're very limited in the fields that we're showing here, but the full download will feature most of the crash and roadway fields in the database that are relevant to safety analysis. And we've worked with the DDSA team to actually decide what order that should be in the columns, so that it kind of matches some of the work that those folks do. If you find you're having trouble with a query, something's not working, you don't think you're getting the numbers that you need, you can click this box and it'll actually show you what the query is that's running. And while that might be a little bit like gibberish to you, you can copy and paste this and send it to one of us, and we can actually paste this into a SQL query and actually see what's happening and why we're not getting the matches that you think you should get.
This might be a good time to just point out the fact that at the bottom of the page there is a bug report link. So if you scroll all the way down to the bottom of the tool there, you see underlined report a bug or request a feature. And that will take you to a web form on the KTC website where you can then paste that code into a chat box if you don't know somebody specific whom you'd like to send that to. And of course, I'm sure, Eric, you would also probably welcome an email with that line of code in it if there was an issue, a specific issue that somebody needed addressed.
Gladly, yeah. And we do actually log all the queries that happen on CDAT. So we can actually go look at the log and see what types of queries people are running, and that'll better inform us of what parts of the tool people are using and what features they're using as we make improvements going forward. So just a little warning that Big Brother is watching you when you're doing query analysis. So similar to the roadway data panel, the crash panel also has a series of charts and graphs. Now, since there were so many charts and graphs and it was kind of filling up the page, we've gone ahead and put them into tab groups. So just generally speaking, you have a bar chart showing the breakdown of Cabco crashes, a day of the week spread, kind of gives new meaning to the hump day in this example, doesn't it, with Wednesday being in the middle. Directional analysis. Now, there's some confusion on what directional analysis is. This is an actual code that's not put in by the police officer, but it's actually something that's derived from several fields that a lot of states, to try to be in compliant with MUC again, have coded up kind of a general term or general crash type by looking at the direction the vehicles are coming into one another. So it really has nothing to do with the compass direction the car's traveling, but just the relative direction each of them are, if there's more than one car, are heading. Now, there's a lot of information in this chart, and this is one of the reasons we actually included the option to show the table. So I'm going to go here and set it to both, again up top, and then that way when I click on this title here, it'll go ahead and switch it to a pie chart, which is way too much information in one pie chart. But then below it'll also give us a nice breakdown of the different directional analysis codes. Now, there are lots of—
a lot easier to read. I can't even read that on my big 28-inch screen here. So
yeah.
I know that one of the pieces of feedback we got early in the tools development was it's difficult to read some of those visualizations. And I think that the access to the tabular display adds a whole lot of value in interpreting this, because you can take both pieces and you can accomplish what you need in terms of both visualization and also looking at that from an analysis standpoint.
Certainly. And I think another thing that we found is that there are just so many directional analysis codes that we've kind of grouped them into smaller, or grouped them into bigger categories that kind of help group the analysis. So right next to the directional analysis chart, we have a directional analysis group. And this one you can almost even kind of read easily just looking at the chart. But again, you can click on that title to get the table and the pie chart here. And really, we're talking about a big other category, and then we're talking about 4 other categories: hitting a fixed object, overturned in the roadway, rear end, and side swipe. So that's kind of what's happening on this route. And if you click here on this link, you'll get information to the different directional analysis groups that we've kind of coded together, binned together. So let me turn this one back. So the next thing that the panel has shown is something we call similar roads. The idea here is that we have picked a divided highway with 4 lanes, 12-foot lanes, 10-foot shoulders, and very little curvature in a large urbanized area. Because of that, we can actually look at the crash characteristics on this segment, this 1 mile segment, and then juxtapose it against similar roads in Kentucky that have those same geometric features. So looking at other roads in Kentucky that match this 4-lane, 12-foot lane, 10-foot shoulder, depressed median, large urbanized area, non-intersection with a curve class of A. These radio buttons here filter the database down to all of the crashes that occur on those types of roads in Kentucky. And what's meaningful here is if you had more than one option in some of these, we are going to limit it to the option that is the most predominant in the section. And this is really helping us get toward a homogeneous segment that we can compare using a safety performance function. So we'll get into more detail about that when we get a different roadway segment in here that has a little more variation. But the idea here is that we're looking at our crashes on the segment and then comparing it to similar roads. And then you can look at kind of the distributions between them and to see if we are dealing with a segment that has more crashes of a certain type than typical or not. So one thing that you might see here is that maybe we're having more crashes on a Wednesday on this segment than when compared to other segments across the state, and there may be some meaningful reason behind that. So does the similar road segment kind of make sense?
Yeah, it's good to have some sort of frame of reference.
Mm-hmm. Now, folks have asked to optionally filter the segments for their region, because you may be looking at some regional differences. So if you wanted to just look at the the 410 or 41210 geometrics in your county or your highway district, you can optionally pick these filters here. But generally speaking, that starts reducing the sample size and it gets a little less meaningful of a comparison. So, and then as you'll see, when we start having a lot more options in our radio boxes here, it can really filter things down in a bad way to where you get very few crashes in the normal, similar road comparison. It's because we're already looking at 3,200 crashes in the state, and we're looking at 87 miles of road that meet this criteria that we're comparing against. So if you start shrinking that down too small, it gets a little harder to make a meaningful comparison. The one thing that this panel points out is your segmentation score. So this is a percentage saying what percentage of the mile segment that we've selected is represented by these roadway characteristics. And that's important because these roadway characteristics are what's going to inform our selection of a safety performance function. We want to pick a safety performance function that matches these geometrics as best as possible. So a segmentation score of 96% is fantastic. That means we don't have a whole lot of variation in this roadway segment, which means when we do pick an SPF, we're going to have a pretty good representation of to compare to. So here I'll show some examples of good and bad segmentation scores as we go forward. But for this segment, I'm going to go ahead and click Detect SPFs, and it's going to take these selections on the radio buttons. Optionally, you could limit it just to interstates and parkways or non-interstates and parkways, and that may be something that helps filter this a little bit better because it'll pull out any interstates that match these criteria. And so that's an option, but I'm going to go ahead and just hit Detect SPF. Based on those geometrics that are selected, it's going to default to an urban multi-lane divided SPF. Knowing what we know about New Circle Road, that's a pretty good match. It is urban, it's multi-lane, it's divided. So that's a pretty good comparison. The next thing that we'll need to select is we generally create SPFs for Cabco, for KAB, and for CO. And those are already loaded in the database, so you can pick between those three. Now this is something that, as we note here, should match your severity score from step one. So if what you pick here is KAB, but when you filtered the crashes, you did it for all crashes, you're not going to have apples and apples, and that's a bad idea. So this should match what you've selected above. Now, it may be possible that going forward, similar to as we'll talk about in the import tool, we may have this automatically selected for you based on what severity score you pick. Maybe take some of the guesswork out of it. But I think for urban multi-lane divided and a severity scale of Cabco, and again, that includes our U's and H's in there, and that's okay. So we're looking at 67 crashes. We're looking at an over dispersion parameter of 0.8, and that is just a characteristic of the SPF model that we picked. We've got a 1 mile road. We've got a weighted ADT, a length weighted ADT of 62,000. Basically, what that does is it takes all the individual ADTs in the segment of road and gets a weighted average of that ADT. So if half of the segment was 60,000 ADT and the other half was 30,000, we'd get a weighted average somewhere in between to give a better representation. Now, the interesting thing about that is crashes may not be uniformly distributed through the segment, and if that's the case, you're really going to want to split your segments up to get a better characterization of that segment. Simply displayed here, we have the A and B parameters of our SPF. And again, that's just going to the database and getting those parameters. The idea here, though, is all of these fields are editable. So if you know for whatever reason there are 3 more crashes that we're not including in here that are in the database and we should consider, just for whatever reason they aren't in our database, and that's meaningful, you can go ahead and change that right here and put in 70. Now, if you do that, we're going to let you know you changed it. The box turns orange, indicating that you've edited some of the data. This is to avoid people kind of cooking the books, so to speak, right? You don't want someone going in there and just modifying data and making it seem like it came out of the crash tool. But there are plenty of good reasons to modify these fields if you know that there's missing information, or if you want to do kind of a what if analysis to say, hey, what if we doubled the ADT in the next 10 years? What would happen? So all that's optional, but it will be flagged. One thing worth pointing out is if you put a non-numeric value in any of these fields, the field will turn red and it'll reset it to kind of a default value, because we can't do calculations on these fields if you enter in non-numeric data. So again, you have the option to change the numbers. Just make sure they're numeric, and make sure that that is something you want to change. So quick review. We have a SPF picked. We have a severity picked. It gets the data for that SPF and matches it to the length and the number of crashes. You have the option to adjust things if necessary. And then the last thing you can add here are adjustment factors. So you can click this link for information about adjustment factors, but basically this is going to be any deviation that your roadway segment has from the base conditions that were used to develop the SPF. All of our base conditions are shown in this adjustment factor link here, and you can look up the urban multi-lane divided highway to see what the base condition geometrics were. And then you can go up to your roadway information page, and you can compare the base condition geometrics to what the segment predominantly has. And from that, you can adjust if necessary. So if this segment had, as we know that this segment has 12-foot lanes, 10-foot shoulders, if our SPFs were based on 4-foot shoulders, there may be an adjustment factor that's available to adjust from 10 down to 4. And if you shorten or make the shoulder less wide, if you make them narrower, that's generally going to increase your crash experience. So you're more likely to have an adjustment factor over 1, because you're going to have an SPF is going to show that the crashes, let's say it's based on a 4-foot wide shoulder, the SPF is going to have more crashes than we're going to have on this segment. Now, since we have a 10-foot shoulder, we're actually going to have an adjustment factor below 1. So whatever the SPF produces, we're going to shrink that down a little bit because we've got a little more room for the cars to move around. Now, these adjustment factors are going to be from other states and based on lots of data, and they're just ways to slightly shift the SPF because of differences in the base conditions. This gets a little more advanced, and this is going to be something that you're only going to do if you really know, if you know the factors and you kind of know what you're doing there. But I've left room here to where folks can put notes in here to say, adjust from 4 to 10-foot shoulder. And you can leave that as a note there, and that way when you print out this report, that information will be displayed, so you have a hint as to why you put that 0.9 in there.
So clear indications for any manual changes that weren't automatically generated, clear indications for adjustment factors, and places for notes, making this tool really valuable for folks that want to print this out and use this for a report, kind of a one-stop shop for their SPF, right?
Yeah, precisely. So as long as you have an SPF selected, severity chosen, all this information filled out, confident in your base condition matching, then you can click the Perform Advanced Analysis. So that'll get us to our last step, which is the safety score. We've got our general disclaimer here, and this is where it's really important to consider your segmentation and to consider the severity that we're using, the SPF model we picked, and have confidence that we're matching our segment to a representative SPF. When you finally get down to this step, we're going to show the crash prediction based on the SPF at this site. We're going to show the EB estimate, which is basically the number of crashes we can expect at this site while accounting for something called regression of the mean. And then we're going to calculate the EEC, which is the excess expected crashes. This is the number that we are kind of hanging all of our the safety score on for this segment. So if folks are used to using critical rate factor to look at a segment, this is the new critical rate factor. It's the single number that we're going to use to represent the safety score of this route. Generally, we're going to use this as a way to rank different segments and so on. The next thing that you see is based on the confidence that we have in this score. Now, if you recall, we had a pretty low theta or pretty low over dispersion parameter for this facility type. This is very likely due to omitted variable bias and the fact that we've got a lot of variation among multi-lane urban highway facilities. So in this case, our standard deviation is such that it's about equal to our EEC, which means this segment could be anywhere between could be anywhere between an EEC of 0 and an EEC of 14. We're unsure kind of where it is in that range, but that's kind of our best guess of the EEC for this segment. Now, what that really tells you is a few things. One, we're not looking at an EEC that is below 0. So a negative EEC is generally considered a roadway that just doesn't have excess expected crashes. The amount of crashes that it experiences is either better than average in that it's lower, or it's about average. So a negative EEC is a good thing. A positive EEC is a bad thing, but the magnitude of it and the confidence around it are the important pieces. So this, if you're comparing this to other segments, and particularly if you're comparing it to other multi-lane urban divided highways, you can use the EEC and the confidence or the standard deviation as a way to kind of see how they all rank.
Would you look at the EEC and then the crash prediction at site and say, okay, if this is 10%, then it's kind of normal. If this is 1,000%, this is way off. Is there any kind of judgment call you can make there, or do you need to compare it with other like roadways?
I think your best bet is to look at the last safety score item, which is the level of service of safety, the loss score. The loss scores are put into 4 categories: 1, 2, 3, and 4. And generally, anything in a 4 is going to be above a certain standard deviation above the SPF curve. So if we have our SPF curve, which is kind of the average that we expect for this segment, anything above that SPF is going to be a positive EEC. And if we're in the upper half of that region, we're going to be a LOS score of 4. But if we're in the lower half, we're going to be an LLS score of 3. Same things happens with 1s and 2s. If we're in a 1, we're in the lowest half under the curve, which again is pretty safe. Or a 2 is in the upper half of that region. And the meaningfulness of this score is you can use this to compare to other facility types or other facilities that are similar, and you're going to have a 1, 2, 3, or 4 that you can use to look at instead of looking at variations in EECs and standard deviations. And some sites are going to have a ton of crashes. Other sites are going to have few crashes, but it really kind of helps normalize that safety score.
Without having to do that comparison yourself, you've got a real quick snapshot of, is
Correct.
this one that really requires additional attention, or maybe this is an average or even below average EEC.
Now it gets very nuanced, and you may look at the benefit cost associated with the type of facility. We may have a really high EEC and it's a 4, but in order to fix that facility, it's going to cost a lot of money. whereas you might have a EEC that's not nearly as high, but it's a LOSS of 3, but the cost to improve or some kind of a systemic analysis that you can, or systemic improvement that you can do is pretty cheap and pretty easy to implement. You might get a better bang for your buck there.
So this is where we would invoke that word engineering judgment.
Yeah. So, all right. We're getting a little lengthy here. So what I want to do is go back to the top. I want to change the segments to something else and show a comparison of how segment score is really important and what that means. So
we did kind of an ideal scenario. Now we're going to do one that's less than ideal.
Yes. So I'm going to look at a very specific segment in Fayette County that I know will illustrate the segmentation issue pretty clearly. So looking at a segment from 0 to 0.945, this is actually a cabinet project. And we did analysis for them using CDAT, using the import tool actually, and provided the segmentation scores and the EECs, and something really jumped out at the segment. So it's a 1 mile segment basically. All severity scores, no filters, leave all these on, click our view data button. So this is for folks not familiar with the mile points. This is Nicholsville Road, and it's going to be the 0 mile marker. So it's the start of Nicholsville Road in Fayette County, which would be at the Jessamine County line, if I'm not mistaken.
Okay, right over by the mall.
Yes. Yeah. Well, a bit south of that because it's not quite, yeah, in the mall area yet, and that's actually kind of the purpose of this. So if we look at the first panel, it's the roadway data. We've got a lot more variation now. Remember before, we basically had all of the same stuff. Now we have most of the mileage with four lanes, some 5, some 6. We've got 11 foot lane widths a little bit, but then mostly 12. We've got a shoulder of 1 and 10, and it's about half and half. We've got a flush median, no median, and a raised median. And again, it's about half and half between having a median and not. It's all large urbanized area, a few intersections peppered in there, but again, we're ignoring the intersections from a crash perspective. And it's a pretty straight road. Okay. Yeah, again, our both setting here is kind of set globally. So in terms of crash data, we have 120 crashes. And again, you can sort based on this to see if it's, certain type of light conditions or different things. You can look at mass PDFs or narratives as necessary. But again, we're going to kind of stick with the high level here. We've got a pretty disastrous directional analysis table here. So if I click on this guy, we can actually see the table associated with all those. And now you can see there are a lot of big groups here where we've got a lot of rear end crashes. And then we've got some specific details of them. But if you're just focused on kind of the general groups, you can actually look at just the directional analysis groups, which kind of simplifies things, gives you a better idea. Again, you can switch between those as necessary. We've got our similar road comparisons going on there. But here's where things get interesting. We've got 4, 5, and 6 lanes, 11 and 12 foot lane widths, 1 foot shoulder, 10 foot shoulder, a variety of median types. Again, the intersections is something we just, we can ignore for segment analysis, and so on. We've got a segmentation score of 0%, which is poor. And we're getting a warning message here saying, hey, the segment that you picked is not represented well by an SPF. And in fact, based on the predominance here, you can see which ones are selected: 4 lanes, 12 foot lanes, 1 foot shoulder, no median, and then so on. What's happening here is we have a lot of length in the 4 lanes and a lot of length in the 12 foot lanes, but if you understand a little bit about the design process for this type of facility, the no shoulder or the narrow shoulder, the few number of lanes, and the no median is going to be one side of the one part of the segment, and then the 12-foot lanes, more than 4 lanes, and having the medians is going to be another section. But because we're based on predominance here, we are mix matching those geometric features to find the most predominant of each one. Ideally, what I'd like to do is say that, Paul?
Which means you won't find an SPF for that.
Exactly. You won't find an SPF, and you won't find a whole lot of crashes to compare it to as well. Because we're only looking at 4.2 miles of routes in the state that match this criteria. And you can scroll down here and see what those are. And none of them are the US 27 section that we're looking at up there, or at least not in its entirety. And because of that, we need the user to put some thought into this to change the segmentation to better analyze the segment. I've thought about ways to try to automate this, and it really just isn't possible at this point to try to figure out what the best predominance is, because we really need the user to shrink down the segmentation. So we're giving it a segmentation score of 0, which should flag everything in your report. If I go ahead and do detect SPFs, it's going to say urban multi-lane undivided was the most predominant it could find, just based on predominance. Now, again, that was kind of a bad guess, but that's the SPF that's picked. Here are the number of crashes, the theta, all the parameters. I've reset our adjustment factor, but it looks like I need to change this back to orange or back to white. So I'm going to go ahead and perform this. It's possible that we're going to have a warning pop up saying, hey, you got a segmentation score of 0. This is a bad idea. But here what we're looking at is an EEC of -93. Now that number really caught the engineer's attention when they got this score from me. And they said, wow, -93, that just does not sound right. I know we have a problem in this segment, and it doesn't seem like -93 is presenting that. So what do? We go back up to the top. We can look at our HIS table, and we can see where things are changing. We've got from 0 to 0.1, 12-foot lanes, 4 lanes. Let's see. As we go down, we see we have no median type, and right about the 0.484, we've got our raised median. Now, what I know about these different types of facilities, that's probably our problem. So we can go up here to our mile point ranges, and we're going from 0 to 0.945. I'm going to go ahead and cut that. And what did I say our number was here? 0.465 is when our median ends. So let's put in a 0.465. Now you can do that type of forensic analysis on the HIS table in general to really find out if there's more changing. But this is the one that I think is the culprit. So now let's look at just from 0 to 0.465. Again, we'll have to, everything gets refreshed. Anytime you change any of the attributes up top here, we clear everything out because you have to start again. And we really want it to be a process where you start at the top and work your way down, because there's some decisions that you want to make. So as we go through here, we're looking at the undivided portion. We're seeing the same table we just saw. Now just the first half. Look at this. Now it looks a lot more like what we were seeing before, where we've got 1 bar for most of our attributes here. That's good. That's a good sign. That's a good sign of homogeneity. Similar, the road is similar. We're looking at 63 crashes. We are looking at these roadway geometrics. Our segmentation score now is 80%. It's got a little grate there. If you printed this out, you probably put a little smiley face on it and hang on the fridge. This is a good sign, right? That's right. So you click detect SPF. Now it's got a little more to work with. It's still going to go with the urban multi-lane. Well, now, yeah, it's still the undivided because that was the most predominant last time. So we're using actually the same SPF as before. All of our crash data here. Everything looks good. Hit perform. Now we're looking at a negative 42. What was the score last time?
90s.
Negative 90 something. Yeah. Okay. All right. Well, that's all well and good, right? Let's go back up to the top, and this you would print out, and this would you'd use as that. Let's now take whatever's left of my clipboard here, plus this guy. So now I'm basically putting in the starting point. That was the ending point last time, and then the final ending point of our segment. And let's scroll down, perform our analysis once again. And again, it's a step-by-step process that we want to work our way down. Again, so you can kind of do forensics, make decisions, kind of sign off on the process, make sure what you're looking at is good. It's going to be a bit slower than if the tool just did it all automatically, but it's a little more sophisticated. So now we're seeing a little bit of variation here, but the median type is flush or raised. Our shoulder width is narrow here. I think that was counterintuitive to what I was thinking. We go from 4, 5, and 6 lanes, but it's pretty small mileage here. So I think we're still looking pretty homogeneous here. As we go down here, this is where we get into the trick where the most predominant section here doesn't match the segment that we're looking at. Again, because of the changing of the 4 lanes and the types of medians, we don't have a match of these geometrics for the whole section, or if you took the most predominant of each one, it doesn't apply to any section, any part of the section, if that makes sense. So again, because we have the most mileage of 4 lanes and the most mileage of the raised mountable, they may not be coincident. And because of that, it's not able to perfectly find the best SPF. However, a flush median and a raised median, we're not really making a distinction there in our SPF analysis. So when we do hit detect SPFs, even though we have a low score, we can still look at it as an urban multi-lane divided facility. So this is just something that's kind of nuanced that we'll have to eventually try to find ways of teasing that out. But it's a warning up top that we don't have a perfect match. But I bet if we lessened that requirement and just said any type of median, we would have a much higher score here. And again, you can go to the HIS table and do that forensic analysis to see what's happening. But going through here, we can pick that SPF, pick that severity type, look at these crashes, and then do the advanced analysis. Our final safety score for this segment now is a EEC of 30.9, standard deviation of 5. So we're looking anywhere between 25 and 35. No matter where we are on that, and that deviation might be related to the fact that we've got variation in median types. No matter where we are, it's still a pretty high EEC. This matches the intuition of the engineer that said, I really know we have a problem in this segment. What the engineer didn't realize is that the problem wasn't on the front half of the mileage, it was on the back half. And because of the way we can go through and look at this step by step, even though this segment has a low segmentation score, there's a reason for it when we kind of understand why that's happening. We still have really, really good SPF metrics here. We've got a particularly high EEC, a low standard deviation, and a standard deviation that not only is it low, but it doesn't dip between negative and positive in terms of the EEC. We've got an LOSS score of 3, so there are probably other segments that are higher, but in this particular one, it's definitely higher than the segment right next to it. So I think the real point of all of this is you want to kind of do this process iteratively and use the data as a way to kind of explain how you should segment and how you should look at it.